Hello everyone, how are you all? I hope you all are well. So welcome back. Today we are going to discuss about the packing efficiency of unit cell. Okay, so in previous video we have already discussed about the different types of unit cell. Today we are going to discuss about their packing efficiency. Now first the question arises that what is the meaning of this packing efficiency? So let's see. Now packing efficiency, when we are talking about, suppose we have a solid and the solid constant particle which we are having, we have considered in form of a sphere. Suppose these are the constant particles and they are closely packed, as in the case of solid it will happen, and forming a solid like this. Okay, so basically these are the constant particles which are present in a specific positions and packing, making a solid. But what you will find, there will be some empty spaces left in between the particles which are forming that solid. Like this is the empty space, this is the empty space, this is the empty space, and so on. What does it show? It shows that whole of the solid which is made by this constant particle are not occupied actually by the constant particle. There will be some space left. So whatever the space which is occupied by the constant particles in a solid is known as its packing efficiency. Okay, because some spaces are never going to be covered by the constant particles, so some spaces are always going to be left. So when some spaces are left, it means whatever the space constant particles are occupying in that solid, that is known as its packing efficiency. Okay, now how we calculate this packing efficiency? Let's see. Now packing efficiency in any solid can be calculated in terms of the percentage space occupied by the constant particle. So packing efficiency, for finding the packing efficiency, the formula is there in case of a unit cell, that is volume of particles divided by the volume of unit cell, and as this packing efficiency is always expressed in terms of percentage, so it is going to be multiplied with 100. Now when we are talking about volume of particles, all the particles which are present in the unit cell, we are considering their shape as a sphere. So basically we are talking about the volume of sphere. Okay, then one more thing is there, multiplied by Z. What is the meaning of this Z? Z means the number of atoms in a specific unit cell, because we have different type of unit cell. So when you are going to find the volume of the particle which are occupying that solid, then in such case the volume of the sphere should be multiplied with the total number of the atoms present in that specific unit cell. Then volume of unit cell, already we have discussed earlier also that here the unit cells we are considered as in the form of a cube, so it should be volume of cube we are going to use. Okay, and then whole thing is going to be the multiple of 100. Okay, so packing efficiency is equivalent to volume of the sphere multiplied by the total number of atoms in a unit cell divided by the volume of a cube and multiply by 100, because it is going to be expressed in terms of percentage. So finally the formula which we are going to get for finding the packing efficiency, I am writing in short like PE as packing efficiency. So it will be 4 by 3 pi r cube divided by a cube multiplied by z, and the whole fraction is going to be multiplied by 100. 4 by 3 pi r cube is a volume of a sphere, okay, where r means the radius of sphere and a means the edge length of unit cell. Okay, pi value you all know. Pi we are going to use as 22 by 7 or maybe use as 3.14. Then Z, we all know, that is number of atom in unit cell. So that is how you are going to calculate the packing efficiency in a unit cell. Now we know that there are different type of unit cell. So we will be going to calculate the packing efficiency of different type of unit cell. Now we are going to calculate the packing efficiency of simple cubic unit cell. One by one we are going to calculate the packing efficiency of all type of unit cell. Simple cubic unit cell, we all know that the type of a unit cell where the constant particles are occupying corner position. Now see, suppose this is a simple cubic unit cell and these are the corner particles which are occupying the corner position. Okay, now we considered every particle as a sphere. So the center of the sphere will be the edges of the cube. So this is the edge length of the cube which we use as A, which we determine as A, and the center of the constant particle will be having some radius. So we consider this radius is R, and same is for the other constant particle, it will be considered as R. Now why we are doing this? Because we need to find the relationship between the edge length and the radius. So from this you can see or you can observe that the relationship between the edge length of the cube and the sphere radius will be equivalent to A is equivalent to 2R in this case. Okay, A is equivalent to 2R, as R plus R equivalent to 2R. So this can be our first equation. Now we are going to write the formula for finding the packing efficiency. Now packing efficiency is equivalent to 4 by 3 pi R cube multiplied by Z divided by A cube, and the whole fraction is going to be multiplied by 100. Now as we know that A is equivalent to 2R, we can also use as R equivalent to A by 2. Okay, so we can consider this also as equation 1. Now suppose this is equation number 2. If we put the value of equation 1 in 2, then our formula will become packing efficiency is equivalent to 4 by 3. Now we can put the value of pi also, that is 22 by 7. Now in place of R cube we can use A by 2 whole cube. Then Z. Now in the case of simple cubic unit cell, the value of Z is going to be 1. So we will be using 1 here. Okay. Then the volume of the cube, that is also going to be A cube, and then whole value is going to be multiplied with 100. Okay. Now further if you solve this equation, it becomes 22 by 7 multiplied by A cube divided by 8 multiplied by 1 divided by A cube multiplied by 100. Okay, we can calculate it and we can cancel the values. We can cancel A cube as A cube. Then finally we will be getting 1100 divided by 21. So approximately the packing fraction of the simple cubic unit cell will be coming 52.4%. Okay, what is the value coming? 52.4%. So that is how we calculate the packing efficiency of unit cell, that is simple cubic unit cell, and that is coming 52.4%. Okay, so it's easy. Every time you have to find the relationship between the radius of the sphere and the edge length. So now we are going to calculate the next packing efficiency of next type of the unit cell, that is going to be body. So students, now we are going to calculate the packing efficiency of the body centered cubic unit cell. Now body centered cubic unit cell, if you remember, is a type of unit cell where the constant particles are occupying the corner position, as well as one of the constant particles is present in the center of the unit cell. If you can see, this is a unit cell where corner particles are there, but one of the particles is present in the center of the unit cell. So first of all we need to find the relationship between the edge of the unit cell and the radius. Now in this case, if you will see, first of all we have to consider a right angle triangle ABC. Okay, ABC, it's a right angle triangle. Now in this case, if you will see in triangle ABC, this is a right angle triangle at B, you will find that the value of we will be using the Pythagoras theorem here, that is the AC square will be equivalent to the AB square plus BC square. Okay, that is the hypotenuse square will be equivalent to the sum of the square of the other two sides of a right angle triangle. Now in this case, if you see AB is equivalent to the edge of the unit cell. So in place of AB, you can write A square. Okay. Now BC we don't know, so BC we need to calculate. Now AC, if you will see, AC means the sum of the radius of the corner particle plus the diameter of the particle which is present in the center of the unit cell, because it is completely coming in between. So the AC will be coming equivalent to R plus 2R whole square. Okay, so this is going to be a relationship. So we need to find the value of BC here. So BC square now will be coming equivalent to 4R whole square minus A square. Okay, or you can use it as 16R square minus A square. Okay, 16R square minus A square. So that is the value of BC we can calculate. So now we have the value of BC square. We considered this as first. Now we will be considering one more right angle triangle, that is BDC. Okay, so triangle BDC, right angle at D, we are considering. So in this case, it will be CD square plus BD square will be equivalent to BC square. Again we have applied the Pythagoras theorem. Okay, that is CD square plus BD square is equivalent to BC square. Now if you see BD is again the edge of the unit cell. CD is also the edge of the unit cell. Okay, so we will be considering its value as A square plus A square equivalent to BC square. Suppose this is your equation number 2. Now if you put the equation of 1 and 2, you will put the value of, you will be using the value of BC square as 16R square minus A square. So finally it will become A square plus A square equivalent to 16R square minus A square. Okay, so basically it comes 3A square equivalent to 16R square, or we can use R is equivalent to, R square is equivalent to 3A square upon 16, or basically R equivalent to what? R equivalent to under root of 3A upon 4. So now this is a relationship which we have established in case of the body centered cubic between the radius of the sphere and the edge. So this can be our equation number 3rd. Now again we apply the formula of packing efficiency, that is 4 by 3 pi r cube divided by a cube multiplied by z multiplied by 100. Now in place of, suppose this is again our equation going to be 4th, then when we apply the value of 3 in 4, what you will find? You will find that packing efficiency will be equivalent to 4 by 3, pi value is 22 by 7. In place of r, you can put root 3a by 4 whole cube, and then a cube is there, and in place, now the value of z, as it is a case of body centered cubic, so the number of atom in a case of body centered cubic is 2. We have already calculated it in the previous video. So the value of z will be using it here as 2, and then whole fraction is again multiplied by 100. Now when you calculate all the things, the a cube will be cancelled with the a cube. The overall answer will be coming equivalent to 68% approximate. So it means the packing efficiency of the body centered cubic is 68%. That is how we have calculated it. Okay. So every time, again I am saying, we have to first establish the relationship between the radius and the edge length, because in the final equation we have to cancel it. So that is how we have calculated the body centered cubic. So first what we have done, we have taken the right angle triangle ABC, established the relationship between the BC and the we have find the value of BC square here. Then we have considered again a right angle triangle BDC, where we have used the Pythagoras theorem again, and we have used the value of BC from the first equation there, and then we have established the relationship. Once the relationship is established, you can put the value and you can write the answer. Okay, so that is how we can calculate it. Now the last one is left, which is the packing efficiency of face centered cubic. Now we will be calculating that. So student, now we are going to calculate the packing efficiency of face centered cubic. This is the last one. Now it's easy to calculate. Now first of all, again we have to find the relationship between what? Edge and the radius of the sphere. Now if you see, this is a face centered cubic where the corner particles are there and one of the particle is present in the center of a face. Okay. So now if you see, this is the edge length of the unit cell, that is AB is equivalent to A as well as BC is equivalent to A, where AC, if you will calculate, it will be R plus 2R plus R. So we will be considering a right angle triangle in triangle ABC, right angled at B. So AC will be our hypotenuse. So AC square will be coming equivalent to AB square plus BC square. Now students, as you can see, the value of AC will be equivalent to R plus 2R plus R, that is R plus 2R plus R whole square, and AB and BC are the edges, so their value will be A only, that is A square plus A square. Okay. So what it will become? It will become 4R square whole square, sorry, equivalent to 2A square, or you can write 16R square equivalent to 2A square, or you can write 8R square equivalent to A square, or you can write A is equivalent to 2 root 2R. That is how we establish the relationship between the edges and the radius in case of FCC. So this is going to be your equation number 1. Once we find the relationship, we have to do it the same, we have to repeat the same thing. That is, again we have to write the formula and we have to put the value of, we have to use the value of A or R, and we have to relate them, and then we have to cancel the value. So again we are going to write the formula for packing efficiency, that is 4 by 3 pi r cube multiplied by z divided by a cube multiplied by 100. Okay. Now 4 by 3 will be as it is, pi value is 22 by 7, r cube will be using as r cube this time. Now the value of z in case of FCC was 4, we have done it in the previous videos, that is z is equivalent to 4. So we will be putting the value of z as 4, then multiply by 100. Now this time in place of a, we will be using the value 2 root 2 r. Okay. So suppose this was the equation number 2. So 1 into, we forget that, we have to write that also, 1 into. So in place of a, you will be writing 2 root 2 r whole cube. Okay. Now we have to cancel all the values, r cube will be cancelled with r cube. Then after all cancellation, you will find that the value, that is the packing efficiency in case of the face centered cubic, will be coming around 74%. And this is the case of, in case of the hexagonal close packing also, we will be doing it later. So in case of the packing efficiency of the FCC, the packing efficiency will be coming equivalent to 74%. So only the important thing is that you have to establish the relationship between the radius of the sphere and the edge. Once you establish, you have to use the same formula and you can calculate. Okay. So now you have learned to find the packing efficiency of the unit cell. So that's all for today. Now in next video, we are going to discuss further about the solid state. So goodbye students. Please like my channel, subscribe it, and don't forget to press the bell icon. Bye bye students.